Okay, hi. I'm going to complete some questions from Stewart's calculus book, section 5.4, number 16 and number 20. Okay, number 16 here is asked to find an indefinite integral. And the key to this problem here is to know a trig identity. So the trig identity is as follows. Sine of 2x is equal to 2 sine x cosine x. So as soon as I replace this sine 2x by this term here, then you'll see that the signs cancel. So let's do that. So I'll have 2 sine x cosine x over sine x. The sine x's cancel. So this integral becomes just 2 cosine x dx. That's all. And the 2 can be ignored for a second here. We'll carry it with us. But the antiderivative of cosine is sine. And we need to add a constant because this is an indefinite integral, as opposed to a definite integral, which would be something like this, number 20 here. Okay, so we'll do number 20 next. When we integrate the 1 here, or to anti-differentiate, we just get an x. When I anti-differentiate 2x, the x, I get x squared. I'm going to add 1 to the exponent. There's a hidden 1 there. Add 1 to the exponent and divide by that, and I still have that 2 out in front. Over here, I'll carry the minus 4, and then let's just get the antiderivative of x cubed. So I add 1 to the 3, it gives me x to the 4th, and then I divide by that 4. I'm going to evaluate all this from the bounds 1 to 3. Okay, let's rewrite it. So this is x plus x squared minus x to the 4th, evaluated from 1 to 3. When I put the 3 in, I get 3 plus 9 minus 3 to the 4th is 81. Minus what I get when I put the 1 in. When I put the 1 in, I get 1 plus 1 minus 1. Okay, so this here, if I, this is 12. If I subtract 12 from 81, I get negative 69. And then here I have another positive 1. Minus 7. Okay, that takes care of those two. And let's look at this integral here. This is number 28 from the same section. Okay, with this one here, the technique that we discussed in class, or one of the techniques that's available to you, is when you're given a fraction here, break it into several fractions. Or in this case, it'll just be 2, as follows. So I'm going to look at that fraction and that fraction. So this integral here is really the integral from 1 to 2. I have y divided by y cubed. That gives me y to the negative 2. And then I have 5y to the 7th over y cubed. That gives me 5y to the 4th. And now I'm ready to anti-differentiate or integrate this. When I add 1 to the exponent here, I get y to the negative 1, and then I need to divide by that negative 1. Over here, in the next term, I'm going to carry the 5 with me. When I do the integral of y to the 4th, I get y to the 5th over 5. And I'm going to evaluate all that from 1 to 2. So that equals, I have negative 1 over y, that's y to the negative 1, plus y to the 5th, evaluated from 1 to 2. When I put in 2, I get negative 1/2 plus 32. That's from this term. Now I need to subtract off what I get when I plug in 1, and that'll be negative 1 plus 1. So this is just 0. Okay, so we end up with 31 1/2.